To start again. Ladies and gentlemen, kindly take your seat. We are about to start the last session of the day. So the last session of the day will be dedicated to maritime and can you? The session will be introduced by Even Flo Dyer-Boyle, who will provide us an overview of the sector, and he will be followed by a presentation of Neil Hangley, who is going to provide us an overview from his perspective on the sector. Let's welcome them.
Hi, everybody. Welcome to the last session. My name is Dara Boyle. I work for Evenflow in Brussels. Recently, we've been doing a market study on Earth observation for the maritime sector for ESA. So I'm going to talk you through that a little bit. But first of all, I'll just briefly introduce Evenflow. So we have three business pillars to our enterprise. Strategic advice and consultancy, which is what we've been recently doing with ESA for the maritime sector. We provide commercialization support services. We recently launched a new service called ScaleWise this year to help startups commercialize their enterprises. And we have a communication and outreach team. So a very brief overview of us at Evenflow here. So let's talk about the importance of the maritime sector. We've got some numbers to show you just how important and vital it is to the world economy. Around 95% of global trade is shipped by sea, 95% of trade by volume, that is. So that equates to about 11 billion tons a year being moved by only 50,000 merchant vessels. It's quite an astonishing figure that 50,000 can move that amount every year. And 20 million jobs are supported worldwide by the maritime sector. So it really is the lifeblood of a lot of economies. I actually have a question for the audience, just to emphasize the importance of the maritime sector. Does anybody recognize the name Ever Given? We have some hands. What was it? Exactly. It was the name of the ship that blocked the Suez Canal back in 2021. And we actually have a Sentinel-1 image here on the left. This is business as normal. On the right, the Ever Given is highlighted up here in the Suez Canal, and you can see traffic backing up on the south side of the canal. Now, this caused major upsets in the global economy. It cost about $9.6 billion a day. It went on for 6 days, so it cost around $60 billion to the global economy. So when you work that out, it's about $6.7 million per minute was lost while this ship was stuck in the Suez Canal. And who could forget the global panic over toilet paper supply? Luckily, this didn't actually materialize. The toilet paper supply of the world remained intact. But I think when you're looking at numbers like $9.6 billion, or $6.7 million. These are obviously huge numbers, but it's hard to get your head around them. But when you tell people you might run out of toilet paper, it kind of puts everything into perspective and highlights the importance of the sector. So as I said, recently we've been working with ESA analysing the maritime sector, the Earth observation maritime sector. We've looked at these 7 sub-segments, so security and emergency management, the likes of dark vessel monitoring, port security, human displacement monitoring via sea, finance and insurance for the maritime sector and where Earth observation can play a role. Renewable energies, so looking at the planning of offshore wind farms, offshore solar floating farms, wave energy technologies. The construction of ports, the construction of other offshore infrastructure that is not renewable, such as oil and gas or offshore pipelines. Transportation, that's why we're all here today, so the entire shipping industry. We looked at the types of dynamics in that particular sub-segment. We looked at pollution monitoring, so emissions monitoring from vessels, but also the likes of oil spill detection. And the application of Earth observation in fisheries and aquaculture, so identifying fish shoals, optimizing aquaculture operations. So the analysis begins with a demand side analysis, user trends. I'll give you just a little flavor of some of the key outcomes that we found here, what the demand side of each of the 7 sub-segments are looking for. In the security and emergency management sub-segment, what they're having to deal with since the end of COVID is maritime safety incidents. They're on the rise. This seems to be a symptom of the world opening back up, vessel traffic opening back up. Safety incidents took a spike after COVID, and they've actually kind of maintained that. So this is an ongoing issue for maritime security and safety stakeholders. Illegal maritime migration is at its highest point in Europe since 2016. We all remember back 2015, 2016, the migration from North Africa up into Europe. That is spiking again. So these are challenges that the maritime stakeholders have to deal with. On the finance and insurance sector, insurance customers are no longer want to deal with generic offerings. They want hyper-personalized insurance offerings. This is something that Earth observation can help out. The construction industry, there's a major focus now in construction on total cost of ownership. So not just looking at the cost of developing a port, but looking at the cost of the lifespan of the port, maintenance costs, operational costs, and even looking at decommissioning costs at the end of its lifetime. This is something that people in the construction industry now really demand of service providers. And seeing as it's a transportation day, some of the findings on the user end when it comes to transportation at sea. Ships can spend up to 40% of their time in port, so essentially wasting time. We've seen some very unique and innovative applications where companies are able to, through the use of AI and machine learning, able to identify demand before it emerges and have an overview of where all vessels are in the world, so you can actually get vessels to ports to pick up cargo ahead of time or in a very short amount of time, therefore increasing profits. Autonomous shipping is obviously going to be a huge major trend. The International Maritime Organization are currently developing a code. We expect it to be in full operation by 2028, which will help dictate and regulate how autonomous ships work at sea. We saw some interesting use cases of pre-voyage forecasting and post-voyage hindcasting in the event of where a cargo may be late to port or undelivered. Earth observation can be used to actually mediate disputes between vessel owners or cargo operators on whose fault it was. So did the ship actually take the most optimum route that day or that time it was at sea based on sea state weather forecasts? Earth observation can look back in time and tell you, oh, it should have taken a different one, therefore the guilty party is party A. And the EU emissions trading system. Next year, 2024, this is being extended to the shipping industry. So this will bring in some new challenges to the shipping industry in terms of monitoring, reporting, verifying their emissions, but it will also open up a lot of opportunities for Earth observation companies to help them do that. So this is a little taster of what things were like on the user end. Now we have to look at how large these subsegments are. So we performed a market sizing calculation here. What you're looking at is, it's actually based on USPA 2022 Earth observation and GNSS data. And these are revenues from Earth observation services, not revenues from data sales. We're just concerned with the revenues from Earth observation services. You've got the numbers in 2022 and the projected sizes in 2031. The circle on the inside is the European market, and the larger circle is the global market. Fisheries and aquaculture comes out on top. A number of reasons for that. The common fisheries policy is really dictating a lot of sustainability now in how fish is caught in Europe. It's also pushing a lot for new technologies to be adopted, Earth observation being one of them for sure. Fisheries themselves get a lot of value from Earth observation. They're very willing to pay for it because of the payoffs they can get in locating fish and optimizing their operations. And then another larger trend across the globe is aquaculture itself. It's the fastest growing market in the world, and we see it come out in the numbers. Security and emergency management came out second. This is a result of continuing geopolitical drivers, as mentioned, illegal migration back at its highest in almost 10 years. Increasing regulatory pressures are a constant thing for this industry. And finally, the utility of Earth observation in security and emergency management. When vessels try to go undetected at sea, they can do very little to hide from the satellites. So we see these two subsegments, fisheries and aquaculture, security, emergency management, coming out on top of our analysis. The total size in Europe, we estimate around 43 million euros for revenues from EO services. And we expect that to reach 80 million euros by 2031. So this is an interesting graph. We've plotted market share in 2022 on the x-axis versus market share in 2031 on the y. If the bubble is somewhere along the horizontal line, it essentially maintains market share. If it's slightly above the horizontal line, it's gaining market share. But the standout bubble here is the big red one at the bottom. The size of the bubble is the CAGR, the compound annual growth rate. Finance and insurance really stands out here as having a really fast growth rate in the next 10 years. And this is a symptom of an even bigger trend in Earth observation, which is the application of Earth observation in parametric insurance products. This came out in the USPA analysis also, and thanks to its objectivity and swift claims resolution, we expect Earth observation for insurance in the maritime sector to be a very big segment. So that was looking at the markets. Now we went into mapping the stakeholders. So starting from the top, we've mapped the authorities and public agencies. These are all the typical ones you would expect. The IMO, EMSA, Frontex, DJ Mare. Some of them dictate policy, some of them enforce policy, and we obviously have the relevant Copernicus and trusted entities at the bottom here. A very important group in the market are the industry associations. They're very influential in the market. They kind of represent the voice of the market, and they often help promote and advance certain technologies. So getting the likes of these on board with Earth observation is a great move to try to promote the use of it. Some of these are Earth observation specialists, so for the likes of ERSC, but some of the associations are Earth observation agnostic, for like for example, Wind Europe, Ocean Energy Europe. So getting these people involved in Earth observation, getting them aware of it, is very important for the market. We also had a look at the research and innovation ecosystem. This is obviously a non-exhaustive list because there's a huge amount of research and academia entities involved here. So we looked at research and academia, clusters and networks. We looked at what other maritime accelerators are doing. For example, the Blue Tech Accelerator currently are focusing on augmented reality and GNSS, applications for GNSS where it doesn't perform very well at sea. And obviously we have the institutional funding bodies. We're at ESA, so we'd obviously looked at incubed ESA business applications. But interestingly, it was mentioned earlier on, Cassini Recently, Cressini gave away the Maritime Prize for 3 innovations who used Earth observation to detect plastic at sea. Then onto the technology side, we've mapped the EO service providers, the EO maritime platforms, and then the EO and information and service providers per sub-segment. You see them all along here. And then right at the very bottom, demand-side users. So we've taken the stakeholder groups and mapped them versus the EO service providers. This is who they would generally be interacting with. And all of this paints a picture of the overall European maritime Earth observation landscape. So this is very nice to have. It gives a good idea of who's involved, who the main stakeholders are. But then the next thing you have to ask yourself is, well, what are they saying? So we actually interviewed, with people you see on the map there, we interviewed 32 stakeholders from users to clusters to EO service providers. We tried to get some qualitative feedback from them on what they believe the needs of the sector are. So this is just a little taster of some quotes we managed to pick out for you guys today from the various interviews we had. So in Arctic and frozen areas, when it comes to vessel detection, false positives are a big issue of floating ice versus a vessel. This is something that needs to be looked into using Earth observation. For the security and emergency management stakeholders, they need really, really low latency services. Time is of the essence in these applications. There's a search and rescue application, there's an emergency at sea. They really, really need low latency services, and some of them are saying they currently are struggling to get what they need. An interesting one, we spoke with the Finnish Coast Guard, and they help with mapping sea ice in the winter in the Gulf of Bothnia between Finland and Sweden. They actually send out icebreakers to break the ice to make way for vessels, but then they have a problem because the mechanical action of breaking ice in very cold weather can actually make the ice reform in a very unstable pattern, and they cannot predict where it's going to go. So something that needs a little bit of attention. And finally, for fisheries and aquaculture, we got some feedback that if you want to increase the adoption of Earth observation in poorer countries, localized weather forecasts for small fishermen that is powered by Earth observation would be a great application. So after all that, we've looked at the demand side, we've sized the markets, we've projected the size of the markets, we've mapped all the stakeholders, we've spoken to the stakeholders to get their feedback, but now we have to identify the potential. So through all of this analysis, we've managed to identify 46 use cases 46 use cases where we performed a gap analysis against each one to understand what the needs of the sector are. And then for each gap that we identified, we used 6 criteria to prioritize the gaps for ESA. So we looked at the 6 criteria we used were market size, market growth, policy priorities. Is there any geopolitical or socioeconomic drivers going to drive the need for this gap? Can current constellations address the gap, or will future constellations address it? And finally, could advanced R&D on the processing side help address the gap? And all of this prioritization is being finished right now just with ESA, and they will be using it to inform an upcoming thematic call. So that's it from me. Thanks very much for your attention, and please reach out. My email is dara@evenflow.eu. Thank you very much.
Right. Well, that's great. Normally I spend the first few minutes when I go to maritime conferences justifying what a person from the European Space Agency does in a maritime conference, but Dare has done the job for me. You're all aware of what space can do for maritime. Still, I quite like the visuals that Stefan presented earlier, so I'm going to do something a little bit similar. I quite like to start with this image of the wall. Many of you probably have recognized that on the light blue you can see the EEZs, and on the dark blue you can see the high seas. The interesting fact is that when you're at the high seas, you're closer to the International Space Station orbit than you are to shore. So that means that anything that happens on the high seas will be better monitored by satellites. And when you have to communicate with those vessels, you're going to be doing so with satellites as well. And why is important? The maritime industry plays a massive role in our economy, but also in our environment. As we have just seen, the maritime transport accounts for over 90% of the trade by volume and over 70% by volume. But not just that, it does it in a very effective and efficient way. Another interesting illustration is, you can see here on the right the MSC Golson. And if you take all the cargo that this ship is carrying at the moment, about 24,000 TEU, and put them in a line, it would stretch from here, ESTEC, until the center of Brussels. That's how effective the packing factor on vessels is. And it's quite efficient as well, because to move all these 90% of the trade by sea, the maritime sector is using about 3% of the global energy and producing 3% of the greenhouse emissions. But that doesn't end here. It's still 3% of the emissions. And there was a target, that is the one on the screen, to halve the emissions by 2050. But that has been now revised on the MEPC 80 this year, and is targeting a net zero emissions by 2050. Is also responsible for over 50% of the marine biodiversity inclusion of non-indigenous species. So this is one of the areas that the maritime industry needs to work on. Other areas of concern are pollution, whether it's in water with oil spills, or noise pollution as well, that is damaging to the mammals, wildlife. Also, safety at sea is an important topic. We have the EMTE report saying that on 2021 there were 14 ships lost at sea and about 35 fatalities. And of course, in the same way that the sea is the path for trade, is also the path for illicit activities, and is the theater for piracy, for smuggling, whether it is migrant smuggling, waste trafficking, or other illicit activities. At ESA, we have divided the maritime activities into 4 pillars: maritime safety and security, maritime sustainability, ports, and the wider blue economy. And we're using and trying to leverage data and space assets from all kind of space technologies, including Earth observation, satellite navigation, satellite communications, and space-based weather, to derive into a number of applications. Those are some of the applications that we have been seeing in the maritime domain, or some of them that we think that there is potential for space to bring value. Rather than going through each of them by name, we're going to be showing few showcases on some of these applications. The first one was a project developed by CNI, where they are merging a wealth of data, including satellite Earth observation, weather, satellite navigation, and AAS, to produce a digital platform that delivers estimated times of arrival, water quality predictions, and a platform for intelligence in port. At the bottom right, you can see some of the water quality forecasts that they provided with the platform. The AAS part is quite an interesting one, because it was a technology that was not developed for space use, though it's been very fruitful for the space industry and the number of space applications that they have been developed. This one, for instance, is not directly used by the space industry, but leverages on the space industry to produce this intelligence product. And is a service that is being developed by ESTEC, a British company, that essentially what it does is to measure the lids of tank fuels in ports, because the lid is a floating lid to minimize losses. And with reflectometry, they can derive the level of the tank, so know the volumes that are available. And then with AIS, track this oil around the world. And they not only can track the volume, but because they know the origin of this oil, they can tell whether it is sweet or sour, whether it's heavy or light, and provide this information well ahead of time. Now, AIS, as good as it is, it has some weaknesses. Mainly that is a voluntary or system that ship captains can switch off when they are involved in illicit activities. Here we have a project from KSAT that they did with the Norwegian Defence Research Institute and Kongsberg Norcontrol to fuse these AIS data with the detection of other RF signals, correlating them as well to SAR images to detect the presence of those dark vessels. Now, AIS doesn't stop here. Is to be followed up with VDES, or as some people refer it to, AIS 2.0. It has been involved in the development of many of the technology, the equipment through GSTP, through ARTIS projects. And we have recently concluded this project, that is BASP, on the demonstration of the services through VDS. Namely, the services that were tested were search and rescue coordination services, ice chart distribution, as you can see on the picture, for navigation through the Arctic, and the MRS messaging. The number of services doesn't stop at the institutional level and at safety and security. Later on, we're going to have a presentation from Lars and the projects that they have for the commercialization of VDES. Now, going back to services enabled by Earth observation, we have Reefer Pulse. This is a company that created a service whereby they use AI with Earth observation to characterize all the different parts of ports systems in conjunction with the GNSS tracking of the ship containers, so that you can know at every instant at what point of the port your container is, and what processes are happening at the time, and that can help to monitor where unauthorized door events have happened, or at what point during the clearance of customs the container is. In here we have a slide missing some elements, but essentially it's one of the first autonomous shippings or non-crewed shipping projects that we did some time ago with SeaKit. This one is on yellow vessels, so vessels that are doing work such as bathymetry studies, which was the case of this particular one, where they use satellite communications to extend the range, the operational range of these unmanned vessels. This particular one was doing bathymetry. We did a project that lasted for 22 days and navigated over 1,200 miles into the east side of the Atlantic Ocean. But shortly after this project, they deployed a vessel into Tonga volcanic eruption, where for safety reasons they could then deploy manned bathymetry vessels. So that's one of the uses of unmanned vessels. Going more towards the present, as we were hearing in the earlier presentation, we are expecting the non-mandatory code for the MASS systems in about next year. And we are already running some projects. This particular one is being piloted by the Italian Coast Guard and Grimaldi Lines. And it uses satellite connectivity and 5G to produce the interface and the entry of unmanned vessels into the port ecosystem. As I was mentioning, we're experiencing regulatory tailwinds, particularly these 3 pieces of regulation that have happened this year or are about to happen are of quite a lot of importance. Starting with the IMO MEPC 80, we have seen that IMO shifted the goalposts from halving the emissions to going net zero by 2050. What is quite interesting is not as much at 2050, but the earlier goal that we have in 2030. And this graph comes from a DNV report, where it shows that in order to reduce the objective of 20% reduction by 2030, instead, the first thing we think when we think about the reduction of emissions is green fuels. But if we are to reduce this 20% only with green fuels, we would need to use about 30 to 40% of all the available green fuels in the world by 2030, which is not going to happen because of all the competitions that there is across different sectors. So we need to think broader than just green fuels and with different solutions. This is one of the reasons why we are launching the Maritime Sustainability Task Force, which is a task force that brings together different stakeholders in the maritime domain, including ship owners, maritime authorities, port authorities, clusters, associations, NGOs, all these people that have an interest and they are vested towards sustainability in the maritime domain, to identify and explore the opportunities that we have on maritime sustainability and how we can address those with satellite data and how we can scale them into a global scale. In here we can see some of the initiatives that we have done in the past. You can see that they cover a broad range of topics, going from plastic-less society to unmanned system, RF analytics. And now on this coming year, we're going to be focusing on 2 main aspects. One of them is in the frame of this non-mandatory MASS code to analyze the gap that there is between existing solutions and the functional requirements that are going to be presented by the IMO to see what's going to be needed for the next generation of autonomous shipping. And the other one is an umbrella call for space decarbonization that is going to be fed through the requirements captured by the Maritime Sustainability Task Force. If you are interested in either of them, you can check on the website business.esa.int or feel free to contact me on my email. And then I'd like to present as well this opportunity that is derived from the presentation that we were just seeing of Evenflow. InCube is about to launch this opportunity that focuses on the use of Earth observation and the development of Earth observation technologies to address any of the 7 pillars that are presented in the in the slide. But there is a focus on the commercial development of these services or technologies. If you are interested in that call, you can access to it through ideas.esa.int or contact Andrea or Michele. Andrea will be hosting the panel next to me, so you can easily identify him. And with this, I'm going to leave space to the panel. Thank you very much.
Thank you very much. Now it's time for the moderation, and Andrea Tulli is the moderator, and I will leave the floor to him to introduce the panelists.
Thank you, Donatella. I have the very difficult task of keeping you awake for 50 minutes while we discuss with very selected guests, which I have the pleasure to invite here on the stage. So I please invite Cosimo, Antonella, Barbara, and Simin here on stage. So first of all, thank you for being here today. I know that some of you traveled long, miles in order to be here. So without any further ado, I will start introducing the participant. So starting from, of course, Cosimo. Cosimo is a senior executive engineer at Energy Saving R&D and Ship Design Department and project lead at Grimaldi Group. Cosimo, do you want to build on that? If it works.
Okay. First of all, I would like to thank ESA for inviting me to this very interesting event. I'm an electric engineer working in Grimaldi Group at the Energy Saving R&D and Ship Design Department. I started as an electric engineer working for the Field Lines OE PLC. This is a Finnish flag company in Helsinki, totally owned by Grimaldi Group. Mainly, I was responsible for all the digital projects of the group, with focusing on the asset management system. This is a system that the group uses in order to manage the maintenance of all our ships. Moving back to Naples in 2013, I started working in the technical department in a division of R&D. And actually, we have different projects ongoing, all related to the energy saving and CO2 reductions. Just a few words about the Grimaldi Group. Grimaldi Group is a shipping company born in 1947. Actually, we have 131 ships totally owned and 27 new ships under construction. All our ships are equipped with the most innovative technologies in order to reach the target of net zero emission that was explained before by our colleague of ESA. Thanks a lot.
Thank you, Cosimo. And then we have Antonella. Antonella Calvia-Goetz works as lead economic advisor focusing on funding, space, and ocean technologies and service in the digital infrastructure division of the project directorates of the European Investment Bank. So Antonella, please.
Thank you. So first of all, I could like to thank the organizer of this fantastic conference. I think we are really into the future. And the bank is a major partner of funding innovation. We generally fund all type of major innovation, from disruptive technologies promoted from startups to major businesses, major technologies promoted by large corporates. We have a total envelope of 72 billion, so we are clearly the financial arm of the European Union. And it's very important to underline that in the last 2 years, we are very much focusing on space and ocean technologies and their interlinkage. In fact, the bank has approved the so-called SESI Strategic European Security Initiative, which set an envelope of 8 billion, almost 1 billion or more than 1 billion per year, up to 27, really to make sure that Europe remains at the forefront of funding innovative solutions for our resilience, automation, which means also savings, net zero, meeting the net zero challenges, and most of all, security. Because we might not know, but as I'm an expert on ocean technologies, Europe has a wider sea than land. So we have really to ensure that our underwater space is fully protected. So I think I stop here, but I would like to remind that I co-authored 2 studies on identifying the RD gap of upstream and downstream space technologies, one with USPA and one we launched the ESA. And I can give a total envelope of 40 billion gap for the downstream sector, and similar somehow gap for the upstream sector. So what was said this morning is very important. You know, speed, capital, talent are the key elements we need to focus upon to ensure that Europe doesn't remain behind and we have full control of our technologies. So this is what it means, strategic autonomy, that the satellites are controlled by us. So with that, I think I stop here.
Thank you, Antonella. We will come back to those points, of course, in the discussion. I would like to give the word now to Barbara Scarnato. Barbara is a principal consultant and team lead at DNV, and she has a distinguished background in remote sensing. So I see that you are not actually represented in the picture, but I think
not
we are,
quite.
we gained from the switch. Yes, of course. Yes. So thank you. The floor is yours.
Thank you. A few words about the company. DNV is the Norske Veritas, is an assurance and risk management company, 14,000 employees with a global reach. DNV has 6 business areas. So Maritime is one, well known for as a classification societies and also advisory services. We have also provide test and certification advisory to energy supply chain product assurance, and we have also a business area, which is the business area in which I'm working, which is digital solutions, in which we are essentially focusing on improving the performance of our stakeholders, managing the risk, and also to provide assurance or digital solution, for example, data-driven solution like AI solution and so forth. Coming to me, therefore, as I work in a unit which is focusing on digitalization and decarbonization, the satellite technology comes as an integral part, both for communication and Earth observation. So therefore, I'm leading the part regarding how to utilize essentially satellite data for the upcoming needs and the decarbonization for all the sector that we have. As with the Green Deal, we have a substantial transformation, and especially for the scope 3 as well, for which sees a supply chain vastly enlarged, and so therefore the normal or traditional mechanism for monitoring, let's say, are not anymore valid. So therefore what we provide is data-driven solution based on integration of different type of data, including satellite data, for verification and also for improving the performance and the risk, managing the risk of our stakeholders.
So thank you very much, Barbara. And last but of course not least, Simin Henkens. Simin is an aquatic scientist with a strong interest in data science. She is currently the senior advisor for the data-driven solution team at Antea Group, an engineering and consultancy firm. So please, can you build on that?
Yeah. Thank you for inviting me to this event. So I'm Simin. I work for an engineering and advisory company called Antea Group for the Belgian division. We are active in a wide array of sectors, from infrastructure to urban planning, but I work for the business unit water. We have several teams active in surface water modeling, groundwater modeling, also the maritime sector. And me specifically, I work for the data-driven solutions team, and we tackle, actually a wide variety of questions that come from customers regarding climate applications, environmental monitoring, both in freshwater and marine environments, and multi-hazard risk assessment and insurance, and so on.
Thank you, Simin. I think we have a very broad, let's say, competencies represented here, both from industries, from banks, from consultant companies. So I think it's, a very, let's say, special panel that we are here today. Finally, I would like also to introduce myself. I am Andrea Tulli. I'm an aerospace engineer and Italian Navy Reserve officer, and I am currently working in the InCube in the Cube office. In the director of Earth Observation in Frascati. So let's start with some discussion then. Cosimo, I would like to start from you. SHIP is entering, as we have seen also from the panels that came before us, a new age of innovation. What are the plans to explore the complex changes that could transform the sector by, let's say, 2035, let's say 10 to 15 years?
Okay, so first of all, I would like to highlight that on 16 September 2020, members of the European Parliament voted in favor in order to include the maritime sector in the EU emission trading system, as explained also before in the previous presentation, with imposing bidding requirements about the CO2 reduction, up to 40% by 2035. And also considering the fuel EU system, there are some other bidding requirements regarding the reduction of the GHG, greenhouse gas emission intensity value, starting from 2% by 2025, 14.5% by 2035, up to 80% by 2050, comparing the values registered in 2020. This means that all ship owners are working very hard in order to reach this target. That's why in our group, we have the Energy Saving in the Ship Design Department that starting from 2017 is working on a different layer in order to reduce as much as possible the CO2 emissions and the fuel consumption of all of our ships. Just to give you some example, in 2020, we delivered the 5th generation of green ships, RoRo ships, is a roll-on roll-off ships, with a huge number of innovative technologies installed on board. Starting from the mega battery pack, we installed on board of 14 ships 5.5 megawatt hours of batteries that we charge during the navigation thanks to the shaft generator, and then use that batteries during the port stay. So thanks to this technology, now we are able to stay in port with zero emission up to 8 hours. This means that we can cover, in all cases obviously, the entire port stay with zero emission. Then highlighting also other different technologies, we have also on board of all our ships the silicon paint that is capable to reduce up to 10% the CO2 emission and consequently the fuel consumption of all our ships. Then we installed also 200 and 400 square meters of solar panel on board of our RoRo ships. It depends from the space available, square meter available on the weather deck. Then we also installed an air quality system on a different level of the decks. Thanks to this system is capable to evaluate, to monitor the CO2 emissions that we have in each deck during the port operation, and is capable to regulate the forced ventilation and so the electric load that we have in port. So for ships that are equipped with the battery pack, in order, if we are able to reduce the forced ventilation, we are capable to increase the number of hours with the zero emission in port.
Which is, let's say, a trending topic in this moment. The fact that we have to, measure and reduce emissions.
Measure and reduce. And in order to measure this, we installed an IoT system, data collector system, on board of all our ships, all ships that are controlled by our company. With the installation of an IoT and few sensors, few devices, we have been able to interface all sensors on board of the ships, starting from the AIS, automatic identification system, that provides the NMA sentences, so VDO and VDM, so we know exactly the position of our ships and the position of the ships of other ship owners. The ECDIS, electronic chart display unit, and also in the engine room we interface the complete automation on the ships. So we have a list of all telemetry parameters, so we know exactly the fuel that we are consumption, starting from the flow rate, density, totalizer, the power registered from our ships, interfacing the torque meter that we have on board.
So just to interrupt you talk about autonomous shipping. Can you please expand on that? Because I think this is one of the trending topics of the future.
Actually, we have two ongoing projects financed by ESA. One is financed by the Smart and Crew shipping program that is called 5G MAS, which partners are together with the Grimaldi. We can find TIM, Telecom Italia Mobile company, Flyside, this is CNIT, the international consortium of research that we have in Italy. That thanks to this system, we are capable to increase the level of autonomous of ships navigation in port waters, utilize the 5G technology installed in port of Livorno. There is a strict relationship between the port authority also and the Coast Guard, because they are stakeholder of the project. And we will use different sensors, starting from smart cameras, LiDAR, RTK, in order to increase the capacity of the sensors in order to register the distance from the hull of the ship to the berth, from meters to centimeters, and also increase the safety of the people on board. Thanks to this technology, we will be able to reduce our OPEX. Because considering in case of bad weather conditions, the master of the ship has to take the decision if it's necessary to call one tugboat, two tugboats in order to complete the berthing phase. Thanks to this system and providing a decision support system, we could increase the safety of the people on board, decided to reduce the OPEX, because consider that when we call it tugboat, it means money for us. And also we could contact the insurance company asking in order to reduce the prime that we pay, providing that we have such a system installed. Then there is another project ongoing that is GSAP, that is financed by the Navis program, that is different from the previous one, because the previous one is port-oriented, the second one is ship-oriented. And thanks to this project, so the main target is always the same, so the increase the level of autonomous of ship during the port waters, but in this case we are interfacing the ship automation. So additionally to the 5G MAS project, in this case, we have the Kongsberg, that is a leader in the maritime sector for the autonomous, and we will interface the autonomous ship to our GSAP system.
I think you just made two great examples on the way in which industry like Grimaldi can benefit from the collaboration with an entity like ESA for the development of this technology that can be also, let's say, easily scaled up. Once you develop this technology for one port on one ship, you can easily
absolutely. You have to consider that this kind of projects, our use case is one ship, but we have 10 twin ships of same category. So once we will complete this system for one ship, we can scale up very, very quickly on board all the other ships. and also for the ships with the same automation. Then consider that Grimaldi is not only a shipping company. We have 2 ports of our properties. We have the port of Wallam in Sweden and the Igoumenitsa port in Greece. This means that we could also extend such technology, considering the integrity and the sense of fusioning that we are developing also on the land side, not only on the port side, on the onboard side.
Thank you. It is, let's say, really, to me as an engineer, is always a pleasure to see how the things that you can just design or imagine, after a while they find the way to get into practical, let's say, applications like this one you described. But of course, you know, in order to have this kind of problem, we need, of course, funding. And here, who is better here to talk than Antonella about how Europe can accelerate the funding of innovation in the field of the new space technologies?
Thank you. Of course, this is a complex debate, but I could like to leave some positive message. First of all, the sea is a laboratory for change. It has been historically so. And in the maritime sector, Europe is playing a sort of leadership role. If you read the ESPA report, again, they are among the leaders in autonomous navigations, in pilots, you know, like Grimaldi. They are, in fact, European companies. The reason being, and we heard this morning, that autonomous GNSS technologies are disruptive, which means, you know, they change really the way customers, operators benefit from the services. And they tend, because these disruptive technologies tend to somehow wipe away existing technologies. And that's why it was reminded this morning, speed is essential. And that's where we are really working all together, the ESPA, ESA, the European Investment Bank, the Commission, to ensure that we have an ecosystem of funding that can provide the means for this acceleration in the transformation of the maritime sector and all other sectors. So the inclusion, let's say, of space technologies basically in every activities we do. I repeat, the order of magnitude of our involvement is for space over 1.4 billion. For example, we funded all the securitization of airport, but also all the major projects concerning autonomous navigation. The challenge concern how we ensure that all these pilots scale up. And for this, the bank, I could say, is doing what it can. We, through the European Investment Fund, we are part of Cassini, which is providing venture capital funds for scaling up, for somehow enable new technologies to achieve a prototype. And the bank itself has an instrument that probably is the best instrument for accelerating technological and transition and commercialization, that is called venture debt. This is a key instrument, it's a patient capital where we take risk as bank, as European institution, meaning when we identify a promising technology which has a business case, we help it in the acceleration process. This means that we can inject capital in the critical moment when these technologies somehow roll out. Generally, as you know, a prototype needs a pilot, as Cosimo would say, in one country, in one specific segment. But when you commercialize, you need to scale up at European level, you need to scale up with different segments, so you need funding, and that's what the banks does. Because we have seen that Europe, again, is great where, in terms of having center of excellence, like in Norway, we have a center of excellence. In France, we have all the Nordic countries very advanced in navigation using space technologies, and also Italy. We are now also working in connecting the various center of excellence in speeding up testing, because that's, we know, is critical, and speeding up also the, how can I say, the adoption of best practice. I don't know how many of you knows that Trondheim, this is like the first pilot site for autonomous navigation. Is a fantastic model of open innovation. I invite some of you to really go and experience this sort of manifestation of the future. And we are trying to disseminate that model across Europe. So we have already connection with Croatia, Spain, Italy, France, so that model technologies that are tested in that specific pilot zone can be fast rolled out across Europe. Why I say that? One of our projects concerned, that was my project because I also act as advisor on the due diligence, was a new technologies for autonomous vessel for ocean monitoring, specifically designed for ocean monitoring of offshore winds. Offshore winds requires massive investment. About 6% is environmental survey. Generally, all the, let's say, research vessels are used. We founded a new company that transformed the business. Basically, it saved 1,000 CO emission using autonomous vessels. By the way, the pilots, half were women, so also transformation in terms of genders and others. And this company, for me, is a great model of what Europe can do. One of the barriers was the fragmentation, or how a company that, in this case, was established in Ireland, can then, let's say, operate fast in all sea basins. And we help, or they help themselves to ensure that their regulatory framework became progressively friendly. And now I could say this company is probably one of the world leaders in the sector, and is conquering project after project, not only in Europe, but also in Canada, in Australia. And this is, for me, a great model of what Europe can do if only we work together and make sure that when we identify what we now start calling the blue champions, we support them. We have to take risk to ensure that they are very fast in the trajectory of establishing themselves. Because this market, I mean, whoever has an industrial economic background like myself knows that disruptive technologies means the winner takes all. So it's very important for Europe to be first and at the frontier.
And this actually connects to the next question that I have is about the fact that, of course, the EIB supports the scale-up and commercialization of this new startup, as you mentioned. So if you can provide us some example or on the procedure in the European Investment Bank adopts in order to achieve this goal.
Yes, I mean, we are about to launch, it should be already public, for example, a specific advisory mechanism. We would like to identify 4 projects that are at the forefront of all the blue technologies, but we know that when we call about blue technology, we think about autonomous navigation, for example, or technologies that use environmental observation to reduce emission, to combat oil spills, and so on and so forth. So our consultant, we identify 40 projects. The best 20, we receive advisory for building up a business case, or somehow to present the investment plan to investors, because that's also a major gap in Europe. How this new technology people talk to the funders. So they need to have the common language, they need to put down an investment plan that is credible, that is feasible, and can enable the investors to take risk. And through this advisory, we will help 20 companies. The advisory is under so-called InvestEU, which is an umbrella funding for all European companies to accelerate digital and green transformation. If you're interested, again, please contact me, because we are in this process of, we call, screening the companies, and this is the first of many probably advisory programs. Is funded under the so-called Restore Our Ocean and Waters mission. That is a program launched by the European Union. But the beauty of this program is that we are really working together, the institutions, industry, academia, trying to identify, we call, without hesitation, the blue champions of tomorrow, to make sure that their technologies are fast scaled up. And we walk the talk, meaning one of the criteria we have for this selection is that in 2 years, this company should be able to receive an injection of capital through our venture capital, which is an injection that can range from 10 million to 30 million, and as an equity sort of investment is really massive. And I repeat, we are a patient capital, so the scope of this investment is to ensure that Europe remain at the forefront of these disruptive technologies.
Thank you, Antonella. I would like to talk to Barbara, and I would like to talk to you about the opportunities and the challenges in the utilization of satellite data in the maritime sector in this case. So if you can build on that.
Sure. The maritime sector is in a deep transformation. And I would say that actually it's, they are like evolving through 3 different points. One is the usual usage of alternative fuels, optimization of operation through different variety of different, let me say, initiatives, which is from the optimization of ship design, or routing, and also the infrastructure. And also here comes as well, like the digitalization as an essential part. There are drivers. The drivers are legislative, has been mentioned already, the ETS, UTS scheme. The Fuel EU initiatives, which will come in 2025. And the supply chain is, as I say, and push, of course, because, I mean, if we have a transportation, a commodity like furniture needs to be transported, and it needs to be transported through shipping, of course, they have a say, because, I mean, they had to comply as well with the low emission in the supply chain, in the supply chain with the scope 3. So there is another driver there, and of course, as Antonella mentioned, so the financial. So there is also like other elements, and I will come after with the concrete utilization in the segment with the satellite data. There are different drivers as well, or trends, which is actually in the OT implementation in the shipping. Which brings, of course, advancement in maintenance, routing, having like the digital twin of the ship in real time for like big ships, which actually have like a giant ship, which actually have latest technology and optimization, therefore the volume for the cargo transport, and bringing also to new economical advantages. And the green corridors, the green shipping as well. Let me say green shipping maybe before, maybe with the alternative fuels, and like the green corridors, like as well for these sustainable zones, essentially for with the practice, let's say. So I mentioned for like example, example of how data is an enabler in all those cases that I mentioned, and it's an enabler in helping, for example, in routing, to have a best routing for the ship, for having less waiting time at the port, which we saw before, which was a significant factor. And also, for example, I had a project, this is also like a concrete example, which was about, during mooring, for example, like ship emissions are very high. So therefore, we had a project which was using high-resolution satellite data, for example, to have a digital mooring layout for different ports, which was an interesting example, and that can be used as well for emission reduction. So this is a point, essentially, that will not come just through a measure. Before I said that there were three pivotal points: fuels, operational performance, which comes in digitalization. So there's a compensation for different ships, a different purpose, let's say, of different elements which need to come to decarbonize or to help the journey. And I mean, for infrastructure management as well, like Earth observation can help in understanding, having a layout of, for example, how busy is the port, what is the activity in the port, if there is any damage in the port. I had also projects which were interested in understanding the vessel traffic in an area, and there was a combination of AES data with different Earth observation data for having an understanding of what is legal or unreported and what is not, because with Earth observation you can have like more aggregated value, what is the total activity. And this is also like a kind of interesting if you're thinking about the coexistence now of these other type of projects we have of different activities. For example, now if a wind farm has to be built, how does it affect the shipping traffic? And also when you have another layer of, which for example now in the north, ice coverage. So therefore, how the ice coverage affects, or how is the new building of assets, wind farm, for example, is affecting the new routes, and also depending on the ice, how the risk of the ship and so forth.
This is about the opportunities. What about the challenges? We would like to hear some concrete example from your experience.
Sure. As I mentioned, for example, we have another project which is EO4BUS, which is we are developing now, and it's a project which is funded from a European Space Agency, and we are collaborating with our Maritime business unit and different stakeholders in the shipping industry. And from ship design and operation to the very end, which is end of life cycle. And it's a kind of interesting because as we have an involvement with the stakeholders, it's first of all very evident that not all the stakeholders there is a very dishomogeneous understanding of Earth observation. So there is an archetype which needs to be considered if the stakeholder had to use in the decision making. The other thing is that, for example, access to data. Even if they have access to the data, at times they don't choose the right data to look at, which is also like an interesting element. Variety of platforms is also like an issue where to access to data. Different data sets come through different platforms, and to orient you need to consider is also like a question of fast accessibility to data relevant to decisions, so can be limiting. And
that's actually a very good point I would like to ask to Simin after your intervention, because we would like to understand a little bit how the satellite data can be combined with the data-driven decision making. And if you can, after your intervention, if you can just give us an example as well.
Let me remember now. Yeah, and the trust, for example, like another element to scale up is a question of trust to data, which is also an interesting point because, for example, coming also to look for different segments. For example, oil and gas had authorities which actually were mentioning that satellite technology, for example, was a good candidate, a good enabler for and a necessary enabler for reconciliation of emissions, for example. And the same, I would say, that actually for the shipping segment is necessary. And also like recommended practice. And so, for example, now we are working on recommended practice to make understand, to make a framework in which is understood what kind of fit-to-purpose data we need to use for achieving the right goal and how to navigate. So in a standard way, let's say. And I can pass.
Thank you very much. Simin, I will ask you the same question, exactly.
Yeah, like I said, our company or our team actually gets a wide variety of different questions, always having the same challenge actually. It doesn't matter if it's really about bathymetry monitoring or pollution monitoring, multi-hazard risk assessment and so on. Everything a customer wants all the time is to get, decisions quick. We get maybe 2, 3, 4 months to deliver advice on always, area of interest that keep getting bigger, resolutions that have to be finer and with high accuracy. And we need to be able to also convince a customer that is maybe not so, that doesn't have that much. That doesn't have that much experience with all these innovative ways of analyze and doing science on data, is to convince them that our models are actually working, that they're correct. And then I maybe get quite quickly into also impediments. So what we see, we have a war for talent, I think, in every company nowadays. And we see, okay, we have some knowledge about using satellite data and remote sense data, but people coming from university, they're often a little bit familiar with optical data, but not so much with radar, which in our countries is important. And we lack the ground truth data, for example. It resonated with me what Cosimo said about the sensors on the ships. We know that so many ships are collecting very valuable data for us, but then they don't measure long enough, for example, or the data that we need is very scattered all around, or it's not really being freely distributed, for example. So to validate models with that we make with satellite data, that makes it quite hard, especially in applications such as, it was also mentioned before, marine plastics, for example, erosion or coastline monitoring. We are a Belgian division, but we also do a lot of international projects, for example, in Western Africa. So just to look at coastline involvement, for example, is difficult. Bathymetry, especially in the rather undeep seas, to measure that is really not easy, and especially not to look at the involvement, also because it's subsurface, and you need for very often radar for that. But it's actually quite interesting to see how data scarce countries and data rich countries like European countries, we still even face similar problems, such as in the Scheldt River, for example, very famous for transportation and dredging and so on. What we still don't have is actually a proper map of the bathymetry of the entire Scheldt River that was taken in one moment in time at a fine enough resolution and for the entire area. And so things like that could be really opportunities, I think, for ESA to look at. And I think the thing that in my experience, come across the most is also analysis paralysis, like we say. So we know that so much space data is being collected, but I think something that the European Union is still suffering from maybe a little bit is the many platforms where you can download them from. Also, a question comes our way and we need to be able to make an offer very quickly. So we need to know where are we going to download the data from, which data are we going to use. And after that comes an entire pre-processing pipeline, and after that comes an entire analysis pipeline, whether it be with classical statistical modeling or AI machine learning. So really to know in advance, like what is actually the result that we're going to reach in the end, which is the problem with data. The data is what it is. We can't do magic on them either. that actually remains a little bit of a problem. It would be amazing if some semantic, now in the world of GPTs, some semantic application would come online where we could just be like, okay, this is our problem that we are facing, this is what we would like to do in this region, and that some sort of robot would help us, also getting along in the entire pipeline of actually eventually arriving at the advice that we would like to give.
Okay. Thank you very much, first of all. I think the intervention were very, meaningful also for the audience, I hope. And we also hear, we heard from industry, we heard from institution, we heard from consultants. So we also heard about the collaboration these people have with ESA and with other institutions in order to, let's say, foster the idea that, using data from space is something that will be even more required day by day. I think our time is over at the moment, so thank you very much, first of all, and goodbye.
Thank you very much. We are arriving at the end of the day. I would like to call on the stage Nick Appleyard, Head of Solution and Application and Solution Department, who is going to give us the final conclusion for the day. And we are waiting for you for our network drink after the event, at least for those who are in the room with us. Oh, sorry. Mistake on my side. It's time for the startup pitches. We missed something. It's a mistake on my side. So let's start with the startup pitches. Again, sorry. Right. Is that going back? Okay, great. Can you take it back from the beginning, please? Right, one more? Right, great. Hi, good afternoon. I'm Georgia. And in the next few minutes, I'm going to talk about marine weather forecasts, and particularly about long routes, super accurate marine weather forecasts can help the maritime industry towards a safer, cleaner, and more cost-efficient future. We've heard it before. The maritime industry is an important emissions contributor, and that is why there are in place strict climate regulations, and now we're looking into a net zero by 2050. And so the actors within the industry are now actively seeking for solutions that work and can actually reduce the blue greenhouse gas emissions. One of the most promising group of solutions is weather ship routing. Basically, the systems consider future weather at sea and propose an optimal route for the ships to keep their fuel consumption and emissions low. However, in practice, these systems do not perform as expected, and that is mainly due to the inaccurate marine weather forecast that they take as an input. Ocean physics is so complex that existing numerical forecast models fail to predict their behavior properly, especially for rough seas. In a long route, we have identified this problem, and we are developing groundbreaking artificial intelligence models which can actually leverage the hidden knowledge of physics that is within good quality historical data, and obviously these include satellite data as well. We're also developing smart API models for an efficient data delivery. But the best thing is that without data as an input and with no other change, existing weather ship routing solutions can perform up to 1.3 times better than they do today. And this can have an amazing impact towards a cleaner planet and a healthier economy. Our team has already proven its value since we have delivered outstanding results in very little time and with limited resources. And now we are expanding the team and we are bringing in new exceptional talent. We're very young, just 1 year old, but our concept has been validated by numerous occasions and prestigious mechanisms like DigiCert Blue Economy Accelerator, Synergies TIC,
accelerator, and of course, is a big risk, which is the reason we are here today. And this gave us the background and confidence to build strong relationships with collaborators and early adopters, and within the targeted market, which is the maritime software market. It's a very dynamic market, this one, and it is driven by the ongoing digitalization, the AI trends, and of course, the pressing climate regulations. And just to avoid any confusion, we are not weather ship routing providers. They are our customers, and we are the data providers, whereas shipping companies are our end users and key market enablers. A very modest scenario predicts a 13 million euro of net profit in 5 years of business. So up to now, we proved that it works. We have our prototype for the Mediterranean Sea, we have our MVP, and now we have a very clear roadmap to develop our first global MMP and serve our potential customers, our early adopters, who eagerly await for this development. So at this stage, we're looking for this missing piece of puzzle, 400K, to jumpstart our exciting journey towards being a global leader in marine weather intelligence. Thank you very much.
Thank you to be here so late. So I'm Alex Stegner. I'm the CEO and co-founder of Amphitrite. It's a young startup as well that comes from a spin-off from research laboratories from the CNRS and the École Polytechnique. And I will show you how AI satellite data fusion can really provide very accurate and very fine scale information for also ship routing. So I just recall things that you already know. 3% of the global greenhouse gas emissions, it's 1 gigaton of CO2. And today, every ton of CO2 counts. So 1 gigaton, it's a big issue. And you already said, I just recall that there is two main pressure, the regulations, the IMO, the carbon intensity index, the EU emission trading system are acting now, are putting a huge pressure on the shipping industry. So what we propose is something different from what Georgia showed just before. The routing today, the global routing is a large-scale routing, basically to avoid the main storms, to avoid bad sea states. Once you did this large-scale routing, meaning change a few 100,000 of nautical miles, you have still the capacity to make slight change on your route, taking into account the surface currents. And here, the scale is much smaller. A slight change of few tenths of 20 nautical miles can have a great impact. You can avoid countercurrents and benefit from positive one. And this is one example that is shown today, which is deployed operationally in the Med Sea with one of our partners. We have one of our clients. And how we do that? It's not from numerical model forecasting, because unfortunately, the numerical model forecasts don't have this level of precision, this level of reliability. We used satellite observation, which are three. You have here visible imagery. You can see a picture of, well, doesn't work, of chlorophyll on the left. In the middle, you have the sea surface temperature, infrared imagery, and you have also the altimeter. So the altimeter gives an information of pressure surface. And you can see the human eye can detect small-scale filaments, eddies, meanders. All that are the signature of surface currents. So we developed a tool based on AI computer vision to retrieve from these informations the surface currents at a very fine scale. So for the last 2 years, thanks to this new technology, which is now patented, we win different calls for tenders, we get different awards, but the most important is that it was tested by a shipping company. And thanks to the ESA program, the ESA VAST program, we were able to perform this operational test to quantify the fuel saving from these first early adopters, these first shipping companies. And now we have 2 other ones that are with whom we are running pilot tests. And this first shipping company is our client now. So today we are a team of 10 experts, combining extensive expertise in AI, computer vision, physical oceanography, satellite data processing, software development as well. So if you want to know more about our products, the innovative ocean data, the reliability index, because we are also able to provide a level of reliability on this data, on this data that we provide, how we give the short-term optimal routing directly on the ships, and how we can also calibrate the fuel oil consumption curves. I will be delighted to answer your questions for the last coffee break, maybe. Thank you.
All right. Good afternoon. I'm Lars Molsen, and one of 2 founders of Sternula, which has been mentioned a few times during today. We are world's first commercial satellite operator to offer AIS 2.0 satellite connectivity. So we are not world's first 100% because there are also 2 national projects, one in China and one in Norway, that came before us. But we are first to do this on commercial terms because we sort of thought that it would not be possible for all nations in the whole world to do their own satellite constellations. So we want to offer this as a service to all these other nations, and at the same time do roaming with those national projects that are going to be there. So why AIS 2.0 or VIDES? It's about connecting with the ship bridge. And now we already had 2 really good examples of why you want to connect with the bridge, because you want to deliver a digital route that the ship can make use of. But the problem is that you don't really want internet on the ship bridge. You want to keep the ship bridge as an isolated system, because in case you open up for IP or internet to the bridge, you would also open up for potential cyber attacks on the autopilot, which would give the opportunity for someone to take control of the vessel and use it as a weapon. So you don't want that. And that prevents digital services in general. It prevents digitalization, and this is what we want a solution for. And the solution is AIS 2.0 or VIDES, VHF Data Exchange System. It's a technology that has been developed on top of the good old AIS system that has been around and helping the maritime world for the past 20 years or so. So in this figure, the dashed lines are the old AIS connections, including also the satellite, although, as it was said before, AIS was not designed for satellite with satellites in mind, but it just happened to be possible with these very robust channels over VHF. And then VIDES, AIS 2.0, has been developed as an add-on, taking into account the satellite link. So now you also can actually do downlink from the satellite. So it's perfect for delivering a weather forecast for these fishermen that were mentioned as who has a need for weather forecasts, digital route, for route optimization systems, and so on. So it's VIDES stands for VHF Data Exchange System, so a data exchange system, but not a connectivity system, really. It's something that can deliver data without an IP connection, and that's the whole idea here. It's really low cost, so it's also something that's available to the little fishermen. And it's a global standard now, an ITU standard since 2022. And yeah, most of the work was done through IALA, and it's about to become a requirement just like AIS under IMO. So our business in Sternula is mainly to provide the satellite connection The coast stations will be done by the local authorities, and then there's also a ship-to-ship option in the technology. So our business is to sell data transport, which can be used for route optimization systems, weather services, port slot booking. So a mix of commercial and public services that will be available to the ship owners, either free of charge if it's provided by the Maritime Authority or by a commercial provider. But we sell to the service provider, typically not directly to the ship owner. So plenty of good use cases, many of them with standardized data formats, standardized under United Nations, under IHO, and to become also required under IMO, these S124, S212, and so on. So a lot of stuff to do with crew safety, a lot of stuff to do with climate action, so route optimization, emissions monitoring, and then also security. Because one of the big problems in the old AIS system is that you don't know who sent the data. There's no authentication, there's no digital signature, but you can add digital signatures in this open data channel of VIDES. Yeah, so it's limited data, it's trust and security, and huge scalability. And in fact, this will become world's largest maritime satellite network by 2030, we believe. So it will have more connections than Starlink on the oceans. Of course, also because it's not just a satellite network, it's also a coastal network and ship-to-ship network. Yeah, so, and yeah, whoops, why can't I go? Can you help me go backwards? Okay, that's, I found it. Yeah, so the total market in 2030 will be around 30 billion euros, and of course we want to get as large a chunk of that as possible. Our company was started a little more than 4 years ago, and we have a flying satellite now since January, and right now we are seeking another 6 million for building the next batch of 4 satellites, and we will need another 8 to 10 million to go for generation 2, which will be another 16 satellites, and then we should be able to finance our own satellites from revenues. And of course, this is for Europe something where we have a strength. It has been the Norwegians in Space Norway, us from Stanola, and then Saab as one of the main equipment providers who has done the big job of getting this into the standardization. So we have a lead now, and we should definitely find a way to make this a European stronghold. Thank you.
Okay, good afternoon, everybody. And I want to just spend the next couple of minutes introducing you to 2 products of SkyTech in the maritime space, which hopefully you will find of interest. To begin with, just to give you a little bit of background, who is SkyTech? SkyTech is a software company headquartered in Dublin, Ireland, and we'd be primarily known for our activities in human spaceflight. So we've, say, for example, developed several software applications which would be used on board the ISS, in particular Columbus, which you can see a very nice model mock-up here next to me. So from our expertise in space technologies, in satellite, in sensors, we have moved to develop 2 software applications within the maritime space. So for our work in space, we've been awarded national awards from the EU and from NASA. And we have, even though we're an SME, we have several offices throughout Europe. So the 2 products that I would like to introduce you to today are what we call the Situation Room and the Satellite Club. The Situation Room is really focused for people that want to ask questions about aggregation and exposure in the maritime space. We provide a platform which people can utilize themselves to upload their marine portfolio to ask complicated questions which they are concerned about. So say if you're an insurance organization, you have a big concern about aggregation. Where are the assets that you are insuring physically located at any one time in case a major emergency occurs in a particular geographical location? The Situation Room is a platform that provides you the capability to answer those questions. It's built upon space technology, so ingestion, AIS, satellite AIS, SAR, EO, third-party databases, RF technologies, so you can get an understanding of assets worldwide and how your exposure might be. So we bring in region monitoring. We provide risk score analytics. What is the probability there might be that ship might have an accident, you might have to pay out insurance. We provide calculated through ML ESG ratings, unique environmental, societal and government scores for any marine asset that is uploaded into the platform. And this is all done autonomously without needing inputs from the operators of those, of those ships. We then also can do cargo analytics by doing port analysis using EO imagery so that you can see exposures of containers, various cargo that is located at a port, all using EO and ML technologies. From the Satellite Club, this is a separate service, all using satellite information, SAR information, and using machine experts we have in-house in SkyTech. So say, for example, it would be a service where you have maybe a concern about an emerging situation. So say, for example, you saw Ever Given as an example earlier. We would have used the Satellite Club to provide EO imagery of that situation, analytics around it. What is your exposure? What is your aggregation? Do your ships have to reroute around Africa to avoid the situation? So if you want to use Earth observation, you don't know its capabilities, but you want our support, then the Satellite Club is the platform for you. And we have several major organizations behind that are using it. So this is an example of people that are using both of those platforms. It is of major interest to reinsurance companies, insurance companies, brokers, loss adjusters, legal counsels. Everybody has different requirements, but these platforms address their needs. So with the SkyTech platforms that you saw, they are now commercial products. They are now being signed up, say several organizations are signing up monthly to use these platforms. It typically is a high value contract and it is really spreading by word of mouth. So say we have the major brokers like Aon have signed up to the platforms, insurance organizations like Chubb, well-known and recognized Tokyo Marine, well-known recognized companies are now using and are commercially signed up for these platforms, and we're finding that that word of mouth is now spreading and further organizations are very actively taking and exploiting the functionality of those platforms. So in summary, why choose SkyTech? We have proven space experience, as I mentioned, with our human spaceflight activities. We have a lot of IPR, we have a lot of ML and patented technologies behind these products. We have unique ESG calculations, which will become more important as you have to adhere to the standards. And we are really first to market in a lot of these technologies. So what I would like to do is that if you are, say, in the marine space, possibly as a customer that these technologies might be of benefit, I'd love to hear from you. If you are maybe looking for a strategic partnership where this software could fit with the products that you are also doing, would be very keen to talk to you. Or if you're a data provider, maybe you see there's another feed which would help these type of solutions, I would be very keen in talking to you. So hopefully that gives you an idea of our products, where SkyTech fits into the marine space, and happy to talk to you further by email or after this conference. So thank you very much for your time.
Hello. So since we are already over time, I'm going to give you a short 90-minute speech. So my name is Karna Tanova. I'm the CEO, co-founder of Awake AI. And well, 5 years ago, my team and I did develop the world's first autonomous vessel. So I was leading that Rolls-Royce business. It happened in Finland, by the way, not in Norway. So important stuff. But now we have developed our next innovation. If we have a video, let's see. Can we get the video, please? Okay. So Amazon, Airbnb, fast food delivery companies, they're all marketplaces that have disrupted existing industries. And Awake AI has now created a marketplace that we call Amazon for Ports. So it's a marketplace meant to automate the buying and selling of port services and products. This is part of the Business Application Space Solutions project. So it has been a 2.5 years development, over 90 user requirements, 250 system requirements, a very complex project in the time of COVID, war, and recession. So we piloted this during the first part of the year until end of July 2023. And now we're able to automate all the buying and selling activities in ports, port services, and linking them together, reporting and invoicing can also be now automated. So it's an AI-based tool for shipping agents. You can call it even an AI agent. The unique marketplace is now trading physical and digital services and products. The main functionalities of the marketplace: you can buy and sell all services, even containing physical goods. You can request quotes and negotiate prices. You can add shopping carts linked to port calls. You can support all different kinds of currencies. You can have digital service subscriptions. You can pay through the marketplace or separately. All the mapping and charts are linked to chats, so you can chat with the whole logistic chain. You have, of course, satellite vessel positions, and you can position the services in the port area when there are usually no really street addresses there. Reporting is automated, and we provide also training, user manual, and user testing. Okay, so this project has now been actually commercialized even before it was finished. So we have Fintraffic, who is a governmental agency in Finland, is our first commercial customer that is developing this national single window. So another regulation that is coming into play is that all seagoing nations need to have a national single window in place. In Europe, it's starting 1st of January next year, and then the rest of the world 1 year after that. So this is the main value-added service that you can now link to national single windows. It's many years ahead of the game, which we see that is becoming compulsory. Besides this, we won an award for this product launch. So it's an award-winning product as well and solution. There are no other similar solutions out there. So we plan to go live Q1 2024 and have about 10 ports and 50 companies using it by the end of 2024. So if you can be so kind and all go to awake.ai/marketplace and click join so we can see you there. Thank you very much.
We've come to the wrap-up. Donatello already introduced me, but I'm Nick Appleyard. I'm the department head for solutions and applications. I'm responsible for the BAS program, which has been spoken about here, part of the commercialization directorate. So it falls to me to try to bring some kind of ribbon around this day's activities. Christmas is coming, and Christmas is a time when everybody thinks about transport. They think about, are we going to be able to get all of our presents through the Suez Canal? Are they going to make their way across the rail freight across Europe? Are the trucks going to be delivering to the stores? Are we going to be able to get the train back to see our friends, our loved ones, the other members of our family? So it's all about transport at this time of year, and transport is the biggest market that we've found for satellite applications in ESA. When we look at across all of portfolio of things that we're using satellites for, that you're using satellites for, transport and mobility is the #1 item on this list, which is why when we designed this schedule of commercialization days, we wanted to go for the transport and mobility first. And that's road transport, rail transport, maritime. We didn't talk about aviation today, but also we didn't talk about space transportation. We have the rockets over there. I think by the time we come around again and we do another commercialization day on transport, that maybe is going to be in the agenda as well, because that's coming. All of this it all comes from integration of multiple systems. Almost everybody who's spoken today has talked about how they're pulling this satellite service and that satellite service and this terrestrial system and that transport system and integrating together something which has complexity. Europe has a great strength in that kind of coordination and integration of complex systems. We work well with each other. We collaborate well. And we need to use that strength. We need to make something from that. This is how we're going to become competitive on the global market and get these services originated in Europe being used all around the world. We've talked a lot about the technical barriers. We've talked about the business barriers. We've talked about the coordination barriers and what we need to do in order to establish the receptive marketplace in which to be able to do that. A lot of talk about what's blocking us, but kind of lift your eyes up a little bit, think about where it is we're trying to get to, what we're trying to achieve with all of this, with this investment of new technology, this innovation, this transformation which is going on across the industry. A lot of it is about efficiency. It's about efficiency of using resources, whether it might be efficiency in fuel and energy use in order to improve the sustainability performance. It might be about time efficiency, and in journey times and not wasting time waiting for transfers between different modes of transport and optimizing route finding. Might be about efficiency of using the assets themselves and not running trucks and trains around empty. Making sure that we have coordinated, planned, integrated systems together to use the resources in the most efficient possible way. It's also about safety, it's about reliability, it's about resilience, and all of these things, again, come from having good flows of information, having good intelligence about what is happening. The topic of sustainable mobility is one of the biggest topics we have in our green agenda in ESA. In terms of the market impact that we think we can have on the sustainability transformations and the green transition that we're all going through. It's around 22% of our investments in that area, which kind of maps the importance of mobility in our portfolio generally. So this is one of the main things that we're looking for from ESA's side to achieve through our investments with you. And this is a commercialization day, and I shouldn't close the day off before speaking a little bit about what we mean by that. Why do this commercially? And we're a public agency funded ultimately from taxes. Why are we asking the private sector to be taking the lead on these projects and to be taking these ideas out there? And in short, the answer is scale. There's always a limit to how much resource an organization, even an organization of the size of ESA, with all of the governments that we have behind us, there's always a limit to how much we can put behind this. We can help you get things up to that first demonstration, that prototype, that first customer. Beyond that, we really rely on the companies to raise finance, to grow their businesses, to take it out there, to find more customers, and really to get the impact through that channel. The impact is going to come from you, from the companies, and from your investors, and from your customers, and from your users. And we need you to pick the ball up at the end of the process of the ESA projects and really run out onto the field with that. We'll invest then to strengthen the infrastructures, to make sure that they're resilient, to make sure that you have a reliable technical and business landscape and marketplace within which to work. ESA will invest for that. And we will invest to help you to establish the products and services which are going to be working within that marketplace. And then it's up to you. That's our commitment to you. That's our challenge to you. So in order to close off the day, I have to thank a few people. Thank you. Thank you for coming. Thank you for spending your day on this. I'd like to thank all of our panelists, all of our speakers who've given us so much to think about today, and the teams across. You have many areas, it may not have been transparent to you, we had many areas of ESA represented today. And I hope it wasn't transparent to you, because that was part of what we're trying to achieve here, is that integration and that seamless connection of all of the different things which have to come together. So I'd like to thank all of my own colleagues for working together so cooperatively around that through today. Thank you to Lucia for recording as we go. Would you just, as a final act, draw yourself taking a little bow with one of your pens? And also, just those who hide behind the curtains, like Oz, the great and merciful. And I thank the team who put together this event today. So Sasha, Olga, Barbara, you give us a little wave over the barrier. Come and take a bow. There we are. And thanks to Donatella, who leads that team and has been the lead of putting together this event, and indeed all of our commercialization gateway activities. So, and with that, I think we can draw the day to a close. As you will see, some bottles have appeared on the tables across this side. I do encourage you to stay, talk to each other, network, make the most of this opportunity when you have so many distinguished and knowledgeable people gathered together. Stay until the drink runs out. Thanks very much.